Last week, if you remember, I know it's been a little while, we kind of started talking about functions. The first lesson, we talked about a lot of different kinds of functions. We kind of got introduced into a piecewise function. And then the next day, we started looking at like doing different things with some of those functions. We looked at the valuation of functions and doing some other things with those functions. Today, when we talk about the algebra of functions, then we're going to take a look at those functions and we're going to do some different things with them. So we're going to do some operations with them. And when we talk about operations, it's our 4 basic operations: add, subtract, multiply, and divide. And we're going to apply that to our functions. And so the way that the problems are going to look today, they're going to give me 2 functions. And they're going to give me maybe an f function and a g function. And then we're going to do some type of operation with that. So let's, in this case, say f of x is x plus 2. G of x is x squared plus 1. Okay, if I ask you to do f plus g of 3, there's 2 different ways that we can go about this. And, sometimes I know people are like, well, why do we show 2 different ways? Well, I think it kind of depends. In some ways, I think one way is easier, and in other ways, I think the other way is easier. And in some ways, you can only do it one or the other, or the best option would only be the one of them. But I'm going to show you both and show you that it doesn't really matter which way you go about it. The first way that we could do this is we could plug 3 into each function and add them together. So I could take 3, plug it into f. I could take 3, plug it into g. And then I could add those 2 answers together. And this time, my answer is going to be a number, because we're actually plugging in 3 to the functions. So if I plug in 3 to the f function, that would be 3 plus 2, which is 5. If I plug 3 into the g function, then that's going to be 3 squared plus 1, which is 10. And then I add those 2 answers together, and I get 15. So we do them separately, basically. That's the first way we could do it. The second way we could do this if I was going to do f plus g of 3, rather than separating them, I'm going to add the 2 functions together. So I'm going to do x plus 2 plus x squared plus 1. We're going to combine like terms, if there's anything to combine. In this case, the 2 and the 1 can combine together. So we have x squared plus x plus 3. Now we're going to take this 3 and we're going to plug it in down here. So this would become 3 squared plus 3 plus 3, which would be 9 plus 3 plus 3, which gets us to 15. Okay, so that's one way to do it. And if I looked at this and if I had to choose which way I would go about it, I would say probably this way is a little bit easier. Okay? Now, there are reasons why I show you this. Okay? There are going to be times where the one on the right might be the way that we have to go about it. But there are going to be times where we're not actually taking a number and plugging it in as well. And so I'll show you some of those different possibilities. Each problem that we do today is going to start with 2 functions. And those 2 functions can be any function that we have looked at throughout all of the first couple of chapters, and especially from that first section of chapter 2. I gave you like all those different options, and we saw x squared, we saw x cubed, we saw absolute value, we saw a square root, we saw linear. Any of those functions are in play here. We can see any of those today. So I'm going to give you some different possibilities here of some different things that we could do. So the first one for part A, we're going to do f plus g of x. And so the difference here is on this one, we're not plugging a number in. On the problem we did just a second ago, we took 3 and we plugged it into each function. So we could separate it, right? We could do 3 into this one, 3 into this one, and then we could put the two answers together. Well, in this case, there's not really any reason to separate this, okay? We just want to take the f function and add it to the g function because we're not actually inserting a number into our functions here. So we're going to say x plus 1 plus the square root of x plus 3. Okay, and here's where it gets a little bit weird because as we look at it and we say, what else can I do here? You see x's, but this x is underneath the radical. So it can't be combined with this x because it's under the radical. Okay, you can't combine like terms here. And so as I look at this, there is nothing to do here. And it doesn't really look like it's simplified, but this right here is our answer. That's all that we can do. We took the f function and added it to the g function, and if we could simplify, if we could combine like terms, we would do it, but there's nothing to do. That's it. Okay? Now, if I took it another step and I said, let's do f plus g of 6, here's where I could go back and do like what I did a little bit ago, right? I could take 6 and plug it in here. I could take 6 and plug it in here and then add the two together. But because I've already written this out, then I'm just going to plug it into this, okay? So now I'm going to take 6 and plug it into the f plus g function, which is this right here, okay? So I'm going to take the 6 and plug it in any place that there's an x. So we're going to go 6 plus 1 plus the square root of 6 plus 3. And we're going to simplify this. 6 plus 1 would be 7. 6 plus 3 is square root of 9. Square root of 9 is 3. And 7 plus 3 is 10. So anytime we have a number right here, my answer is going to be a number, okay? If we have a variable here, then my answer is going to be an expression of some kind. Okay? And so that's where you really got to pay the difference. And that's really the big difference between all the problems today. Am I actually evaluating it where I'm going to take a number and plug it in, or am I going to leave my answer as some type of expression or equation? Okay, another one here. Just some things to watch out for. Kind of like we did with part B. Instead of plugging in 6, now we're going to plug in -4. So we're going to put -4 wherever there is an x. So we're going to go -4 plus 1 plus the square root of -4 plus 3. Okay, as we start to simplify, because we have numbers here, we get -3 plus the square root of -1. But when I see the square root of -1, as of right now, what does that tell me? Can't be done, right? Even if you tried to put that into the calculator, your calculator would say, hey, wait a second, you can't take the square root of -1. It would give you an error message, okay? That will change when we get into imaginaries, but that won't be till chapter 3. So for right now, anytime I see the square root of a negative, then that's a big red flag, okay? We can't do that. And so here we would say my solution does not exist. There is no number, or no solution, or there's a lot of different ways that you could say it, okay? Because we can't take the square root of a -1, we do not have a solution here. Last chapter, we talked a lot about denominator, like what values of x can't we have? So denominators are a big red flag, radicals are a big red flag. Anytime I have those two things, those are the times that I really got to watch out for values that may not work, values that may not give me an answer. Okay, I had told you at the beginning of the chapter that they sent me an email over Christmas break, and they have eliminated some things out of chapter 2. And I think that's a good thing. This is one section that they took a bunch of stuff out. We're not going to focus on, you'll see in the textbook, they're going to ask about the domain of a lot of things. That's kind of why I'm telling you about this. We're not going to necessarily worry about the domain of some of these things. We're just going to do the actual operations, the add, subtract, multiply, divide. So you're going to have some problems today where it's going to have a list of about 5 or 6 parts. Anytime you see the domain part, you don't need to worry about the domain parts of it, okay? There's also another thing called the difference quotient, which we're going to eliminate. And so that is not part of something we're going to go over in this section either. So been some big topics eliminated from this section in particular. Hey, I'm going to show you one like what I was just talking about. I'm going to give you 2 functions, which is how most of these are going to start. And we're going to use these 2 functions for the entire problem. And we're going to do multiple parts here. So I'm going to give you a lot of different possibilities of some different things that we're going to see. I'm going to give you all 4 operations, add, subtract, multiply, divide. And then the last one is one where you use the same function multiple times. Okay, and we can use it as many times as we want, whatever the problem states us to do. But we're not doing any evaluating here. Okay, we're just taking it, we're looking at it and trying to determine what we got. Okay, so we've already done one like part A. X squared minus 4 plus, I kind of like to put these in parentheses just to kind of separate them. Here's the f function, here's the g function. We're going to add them together. And what we always want to do is try to simplify if we can. If I can do anything to combine like terms or simplify this, then we want to do that. And so in this case, the x squared and the x, nothing can combine, but I have a -4 plus 2, which would be -2. And that would be our answer. That's all we got to do. Okay. If there was a number here, then I would take that number and I would plug it in here. Okay, but we don't have to do that in this case. We're just, so anytime we see an x right here, we know our answer is going to be some type of expression like we have here. But always simplify as much as possible. Okay, f minus g. Here's one of the main reasons why I like putting this in parentheses. If we don't put this in parentheses, typically we're going to miss this problem. Okay, and I'll show you the biggest mistake that people make. If we don't write it out with parentheses, then we're going to miss the biggest thing that's happening here. I'm taking f minus this whole thing. But now that I see parentheses here, when I have a minus sign in front of this parenthesis, what am I going to have to do with this minus sign? You gotta have to distribute it, right? It's gotta go to both parts. If I don't put parentheses here, you're gonna forget to distribute it and you're gonna get a different answer, okay? So the way that I write it out is kind of a big deal. And so we're gonna simplify this now. X squared minus 4, nothing changes there, minus x minus 2. And then we can combine like terms. And then that would be our answer. Okay. So you gotta be really careful of your signs. That's probably the biggest mistake that gets made here is we forget to distribute, we forget to carry that negative throughout. Okay, part C is F times G. So we're going to take F, multiply it by G. So as I look at this one, what would be the first thought that comes to mind here that we'd have to do? Got a binomial, multiplying it by another binomial. FOIL, yeah. It's just a good old FOIL problem. We haven't seen it for a little while, right? But this is just a good old FOIL problem. So we're going to take x squared times x, which is x cubed. We're going to take x squared times 2, negative 4 times x, negative 4 times 2. None of those will combine together, so that would be my answer. Gonna have to kind of remember some of your exponent rules. When I multiply those together, I add their exponents and some things like that. Okay, so that's just a FOIL problem. Okay, for part D, F divided by G. The first part of this looks pretty straightforward. F is x squared minus 4. G is x plus 2. So we put the f function on top, we put the g function on bottom. That's pretty straightforward, right? But here's where we got to be careful, okay? And you won't be able to do this every single time. Sometimes I might just be done right here, okay? But we're not quite done on this one. So here's another thing that we haven't seen for a little while. Something that we got to kind of keep our eye on. When I see x squared minus 4, where have we seen that before? What can I do with x squared minus 4?
You can
Factor it, okay? And what kind of factoring is that? Remember? Or what does it factor into?
the x plus 2 and x minus 2.
Yep, x plus 2, x minus 2. That's what we call DOPS, difference of perfect squares. X squared and 4 are both perfect squares. So it factors into x plus 2 and x minus 2. And we have an x plus 2 on bottom, which we can't factor. But the reason why this is now helpful is because if I look at my top and my bottom, I see that they have a common factor. So I can knock those common factors out. And once again, we always want to simplify as much as we possibly can, if I can. Sometimes we can, sometimes we may not be able to. But in that case, by factoring it. Okay, so we haven't seen FOIL for a little bit. We haven't seen factoring for a little bit. And that's probably one of the biggest things about college algebra is like we haven't gone and done any sections on some of those common algebraic things. But those are things that we've done really back since Algebra 1. We start talking about foiling and factoring all the way back. And then do it again in Algebra 2. But even though we've done it before, we don't really have any sections where we kind of practice some of those concepts. So are we going to see them from time to time? Yeah, we're going to see factoring. We're going to see all of our different types of factoring methods. But here it just kind of showed up out of nowhere. We haven't seen it for a while. Okay, the last one in this group is g times g. So the g function was x plus 2, and I'm going to take it times itself. So in this case, we're not even using the f function. Okay, and kind of like I said before, These are the two functions that we're going to use for this entire problem. Okay? And that's kind of why they do like 4 or 5 parts, so they don't have to give you a new function every single time. We're going to use those same two functions over and over and over again, just doing different things with them. So here we got x times x is x squared. And then we got 2 times x, and then 2 times 2. So we have x squared plus 4x plus 4. So it's just another FOIL problem. So the good news is, with all the stuff that they took out of this section, then that's it. That's all we got for today. The last part that they took out, I think that was a good subtraction because it was kind of a tricky concept. So that's all we got for today. Fairly short lesson and pretty short assignment as well. I will tell you that some of